Today we're going to talk about probability. And a lot of this you have seen in middle school. So the whole front page, you should know how to find simple probability. But we'll go back through, make sure we know our definitions and some words. And then we're going to extend this to those Venn diagrams that we talked about last lesson and how to find probability from those as well. So we'll start with some vocabulary and then we'll get right into some examples to go with those. So the word outcome basically is a possible result, okay, of an experiment or an event. Same thing with regular English. An outcome is what could happen. Okay, what was the outcome of the game? Who won the game? That's an outcome. The sample space is a set of all possible outcomes. Okay, so if I list out all the things that could happen, that is my sample space. And we'll do an example of that. And then probability is the likelihood that an event will occur. So we can write this as a fraction, a decimal, or a percent. I'm going to stick with the fractions because that's just easiest at this point, but you can write them as decimals or percents as well. And then our symbol is this capital P. Okay, if you see that, that means probability. Okay, and so to find probability, we have to find the number of, we'll call them favorable outcomes. So what are you looking for? Okay, divided by the number of total outcomes. So it'll be really important that you either list out your sample space, or you can see your sample space or think about your sample space so you know how many different things could happen, because that's going to give you your number of total outcomes. Okay, so example 1 says, suppose you roll a 6-sided number cube, which is basically a dice. For some reason, they like to call them number cubes. So if you see that, it's talking about a regular dice. So letter A says, what is the sample space? So we said the sample space is a set of all possible outcomes. So if we roll a dice, what are the possible things that could happen? Okay, you could roll a 1, 2, 3, 4, 5, or a 6. Okay, because it says it's 6-sided. So my sample space would be all of those things listed out. So you can see there are 6 different things that could happen. Okay, so letter B says, what's the probability of rolling a 1? So the number of ones that I have 1, 1. That's the number of favorable outcomes. Okay, over the number of total outcomes. So there's 6 different things that we could roll. So probability of rolling a 1 would be 1 out of the 6 options. Okay, letter C, what's the probability of rolling an even? So we need to count how many evens we have. So 2, 4, and 6 are all even. So there's 3. Okay, and there's still 6 options total. So 3 out of the 6 are even. So 3 over 6, or you can simplify that to 1/2. Okay, so you just find how many there are, and then you divide by the total number of options. All right, and then we'll do one more example here, and we'll switch over to the Venn diagrams. So we've got a box of candy here. So we've got grape, cherry, lemon, and that's it. Okay, so we have different candies here. So letter A says how many events are in the sample space. We want to see how many different things could happen. And now some of these do repeat, and you still want to count them because that tells you the total number of candies we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15, okay, different options. We really should call these outcomes that are in our sample space. Okay, so that's going to be what we divide by. So B says, what's the probability of getting a cherry? Remember that P means probability, so of drawing a cherry. So we need to count how many cherries we have because we could draw any of those. So 1, 2, 3, 4, 5, 6. So there's 6 cherries out of the 15 total we just counted. So 6 out of 15, or you can simplify that by dividing them both by 2. And that gives me, not divide by 2, divide both of them by 3, and that gives me 2 out of 5. Okay, letter C, what's the probability of drawing a lemon? So we have 1, 2, 3, 4 lemons. So 4 out of the 15. Okay, and then the last one was the probability of drawing a lemon or a grape. So I just kind of added this in, but for lemons or grapes, that means you can draw either one. And so we want to just count all of them that are either lemon or grape. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there are 9 that are lemon or grape. Okay, so 9 out of 15 total. And then we could simplify that, divide them both by 3, and that gives me 3 out of 5. Okay, so that's basic probability. Just count how many there are out of the number total. So on the back or the second page, okay, we're going to use that idea and kind of shift it over into the Venn diagrams. And so it's still the same concept. We're just using those Venn diagrams to give us some ideas. So at the top, we're going to recap the things that we learned last lesson. So this first one, remember that symbol that looks like an N? Okay, that's intersect. So A intersect B is where they intersect or cross each other or what they have in common. So that would represent this middle section here. Okay. Number 2, the one that looks like a U, that's union. That's putting A and B together. So anything that's inside A or B. Okay, even counting that part in the middle, because that part is in both, and that's fine. It is in at least one or the other. And then number 3, the A with the apostrophe, that means not. Okay, so that means everything but that section, or cover up A, and we're going to shade everything else. Okay, so not A, so that means cover up A, and then you could shade the rest of B, and then you can also shade the part on the outside, because we will have some numbers on the outside as well. Okay, so those will be the 3 main ones that they ask for. So you should be able to use those. Now number 3 could change. It could say not B or not another section here. But if it says not, just kind of cover up that section and then shade in everything else. Okay, so we'll do 2 examples here, and then you should be good to do your practice. So in this first Venn diagram, we've got owning a skateboard and owning rollerblades. So we're going to make A the skateboard and B the rollerblades. And it doesn't matter which one we use here, but we're just trying to put names to what A and B are. Okay, so first thing I would do is go ahead and add up all of your numbers, because that's going to tell you your total number of outcomes. So we have 100 numbers total here. Okay, and this is representing people. So there's 9 people in this section, 39 in this section, 3 in this section, 49 here. So everything we're going to divide by 100. Okay, so probability of A. So A is my skateboard. So remember, A is this entire thing here. So how many people own a skateboard? We would do 39 plus 9. So that gives me 48 out of the 100 total. And I'm not going to worry about simplifying here. We're just going to write them down. Okay, probability of B. That's this circle here. So 39 plus 3, that entire circle. So 42 out of 100, and make sure I would outline the full circle, because a lot of times people just put that one number. Okay, probability of not A, so we're going to cover up A, and that leaves me these 2. So 3 plus 49, okay, is 52 out of 100. Okay, probability of not B, so cover up B here. So we have 9 and 49. So that gives me 58 out of 100. Okay, so this one's A union B. So if you look back up at our section here, okay, that's all of this. So adding 9 plus 39 plus 3, and that gives you 51, I believe. Yep. So 51 out of 100. And then the last one, that looks like the N, that's intersect. Okay, that's where they cross. And you shouldn't have to add for the intersect, you're only adding for the union. So intersect where they cross is this part right here. So that's 39 people out of the 100. Okay, and those are the people that own both a skateboard and rollerblades. Okay, so it'll all look pretty similar to that. It's just getting this notation down. So we'll do one more example. If you want to try it by yourself and then come back and check with my answers, that would be a good idea. But if you don't, you can just kind of go through with me as well. So we need to add those together. So 328 plus 425 plus 600 plus 151. So this one's a big total. So 1,504. Okay, so let's do A is the allowance, and B is the household chores. Okay, so these are the people that just get an allowance for doing nothing apparently. These people do chores and get allowance. These people just do chores, and then these people don't do either. Okay, so probability of A, so that's my whole A circle. We need to do 328 plus 425, that entire thing. So 753 people out of the 1504. And I'm not going to worry about simplifying here. I know not everybody has good calculators. Okay, probability of B would be this entire circle here. So that's going to be 1,025 out of my 1504. Okay, 600 plus 425 gives me 1,025. Okay, probability of not A, so cover up A. So 600 plus 151. So 751 out of my total. Okay, probability of not B with the apostrophe. I know they're little, but you got to be careful. So cover up B. We're doing 328 plus 151, which is 479 out of my total. Okay, and then the U is the union. You put those together. Okay, everything inside of the circles. So 328 plus 425 plus 600. So 1,353 out of our total. Okay, and then the last one is intersection, the one that looks like an N. So where do they cross or where do they have in common? And that's the 425 out of 1504. So that's this part right here. Okay, so these symbols are the same ones at the top if you need to go back and look at that so you know which sections to add together. Okay, so hopefully that helps. If y'all would do your practice, then they should be pretty similar to the examples on here.